অ্যাকচুয়ালি প্লাজমা জিনিসটাকে আমরা বলেছিলাম যে একটা সিস্টেম যখন আয়োনাইজড হয়ে যাচ্ছে আর কিছু স্পেশাল ক্রাইটেরিয়া যদি তারা স্যাটিসফাই করে তাকে আমরা প্লাজমা বলি। তো প্লাজমার মধ্যে যে প্লাজমা পার্টিকেল গুলো থাকতে পারে আয়ন থাকতে পারে, ইলেকট্রন থাকতে পারে, নিউট্রনস থাকতে পারে। কিন্তু আয়ন আর ইলেকট্রনের সংখ্যাটা নিউট্রনস এর চেয়ে অনেক বেশি হয়ে গেলে তাকে আমরা প্লাজমা স্টেট হিসেবে সাপোজ আমরা তাদেরকে প্লাজমা স্টেট হিসেবে ধরতে পারি। একটা সার্টেন মিনিমাম লেভেল অফ কনসেন্ট্রেশন অফ দ্য ইলেকট্রনস এন্ড দ্য আয়নস তাকে আমরা প্লাজমা বলতে পারি। তো সেক্ষেত্রে আমরা ইকুয়েশন অফ মোশন কনস্ট্রাক্ট করেছি। ইলেকট্রনের ইকুয়েশন অফ মোশন কেমন হবে, যে m dvd by dt is equal to externally applied electric field E plus minus gamma of v। তো এই গামাটাকে বলেছিলাম কলিশনাল মানে কলিশন ফ্রিকোয়েন্সি, অর্থাৎ পার ইউনিট টাইমে যতগুলো কলিশন হবে সেটাই হচ্ছে গামা। তো এই পুরো টার্মটা এটাকে বলা হয় কলিশনাল ড্র্যাগ ফোর্স। কলিশনাল ড্র্যাগ ফোর্স অর্থাৎ এটা খানিকটা ওই ড্যাম্পড অসিলেটরের যে ড্যাম্পিং ফোর্স সেটারই মতো। ড্যাম্পিং ফোর্স ইজ প্রপোর্শনাল টু দ্য ভেলোসিটি হয়, এখানে সেটা ড্রিফট ভেলোসিটির সঙ্গে প্রপোর্শনাল। তাই আমরা এটাকে ভাবতে পারি যে সেটা একটা ড্যাম্পিং এর কাজ করছে। দিস টার্ম ইজ অ্যাকচুয়ালি রিপ্রেজেন্ট দ্য ড্যাম্পিং। ওকে, তো ইন জেনারেল বাকি আরো কিছু টার্ম ছিল, যেমন হচ্ছে পার্শিয়াল প্রেসার ফোর্স একটা ছিল, বা অন্যান্য যে টার্ম গুলো ছিল সেগুলো আমরা এখানে নেগলেক্ট করছি। তো একটা প্লাজমা যেখানে আমরা কনসিডার করছি অনলি দ্য এক্সটার্নাল ফোর্স, এক্সটার্নাল ইলেকট্রিক ফিল্ডের জন্য একটা ফোর্স, আর হচ্ছে কি কলিশনাল ড্র্যাগ ফোর্স which is proportional to the velocity and it is negative due to the deceleration। ভেলোসিটির অপোজিট দিকে এরা কাজ করবে কিন্তু ভেলোসিটির সঙ্গে প্রপোর্শনাল। তো এখান থেকে আমরা যদি এটাকে সলভ করতে চাই তাহলে কেমন আসবে, m dvd by dt plus gamma of vd is equal to e। এটা সো এটাকে লিখতে পারি যে d by dt plus gamma by m of vd equal to e by m into। তো এই ইকুয়েশনটাকে আমরা সলভ করেছিলাম আগের দিন কিভাবে, না ইন্টিগ্রেটিং ফ্যাক্টর গুণ করে, অর্থাৎ বোথ সাইডে আমরা যদি এরকম e টু দি পাওয়ার গামা বাই m টি গুণ করে দিই, e টু দি পাওয়ার গামা বাই m ইনটু t যদি গুণ করে দিই, তাহলে এই পুরো জিনিসটাকে আমরা লিখতে পারি যে d বাই dt অফ e টু দি পাওয়ার গামা বাই mt ইনটু vd। এটা দ্যাট ইজ ইকুয়াল টু কত, না e বাই m e টু দি পাওয়ার গামা বাই m ইনটু t। এরকম। তো এই যে এক্সটার্নাল ইলেকট্রিক ফিল্ড যেটা এটা কত লিখি আমরা, e0 e টু দি পাওয়ার i বা মাইনাস i k ডট r মাইনাস ওমেগা। এরকম যদি এক্সটার্নাল ইলেকট্রিক ফিল্ড থাকে তাহলে এখান থেকে আমরা কি সলিউশন পাবো, এখান থেকে আমরা সলিউশন পাবো e টু দি পাওয়ার গামা বাই mt ইনটু vd দ্যাট ইজ ইকুয়াল টু কত হবে, e বাই m ইন্টিগ্রেশন e0 e টু দি পাওয়ার মাইনাস i k ডট r একটা টার্ম থাকবে, আর e টু দি পাওয়ার i ওমেগা t মানে e টু দি পাওয়ার i ওমেগা প্লাস গামা বাই m ইনটু t এরকম একটা টার্ম থাকবে dt। এটা থাকবে। ওকে, তো এখান থেকে ইন্টিগ্রেশনটা করলে আমরা কি পাবো, e বাই m ইনটু আফটার ইন্টিগ্রেশন, এগুলো কোনো ইন্টিগ্রেশন হবে না, এটা টাইম ইন্ডিপেন্ডেন্ট পার্ট। নিচে একটা কি আসবে, গামা বাই m প্লাস i ওমেগা তারপর আবার E0 পুরো টার্মটা চলে আসবে, অর্থাৎ এটাকে আমরা E লিখতে পারি, প্লাস একটা ইন্টিগ্রেশন কনস্ট্যান্ট সি মে বি ভেক্টর হিয়ার, কারণ যদি লেফট হ্যান্ড সাইড ভেক্টর হয় তাহলে রাইট হ্যান্ড সাইড যে ইন্টিগ্রেশন কনস্ট্যান্ট সেটাও ভেক্টর হবে। ওকে, সো VD is actually of course এই টার্মটা ছিল, অর্থাৎ e টু দি পাওয়ার গামা বাই m একটা থাকবে এটা, তাহলে VD ইকুয়ালস টু কত হবে, E বাই m ইন্টু 1 বাই গামা বাই m প্লাস I ওমেগা প্লাস C e to the power minus gamma by m. Okay. This is the solution for drift velocity under plasma, drift velocity of electron under plasma. সেটা আমরা দেখতে পাবো। তো এবারে যখন স্টেডি স্টেট আমরা পাবো, অর্থাৎ দেখছি এখানে একটা এক্সপোনেনশিয়ালি ডিকেইং ফ্যাক্টর আছে মাইনাস গামা বাই m। তো গামা যদি খুব বেশি হয়, অর্থাৎ গামা লার্জ or large gamma, this decaying factor dying very quickly, অর্থাৎ এর টাইম কনস্ট্যান্ট বা রিল্যাক্সেশন টাইম সেটা খুবই কম হবে। রিল্যাক্সেশন টাইম টাও is equal to m by gamma. Whenever large gamma is very large, tau will be very small. So quickly this term will be decayed. So after sufficient of time at steady state, we can write Vd is equal to E by m into 1 minus gamma by m plus I omega into E. Okay. That's like that. So also you can write this is EE by gamma plus IM omega. You can also write in this form. M টা multiply করে দিলে তোমরা এরকম পাও। Okay. So Vd is equal to that drift velocity. Again, you know the conductivity sigma. Okay. Before going to sigma, we have the Ohm's law, J equal to sigma E, right? This is the consequences of G equals to IR. These are same to same. J equal to sigma E and V equals to IR. They are actually there. এটাকে আমরা এখান থেকে পাবো আর এটাকে ওইখান থেকে পাবো। So this is the modified form of Ohm's law, J equal to sigma. So in order to find sigma conductivity of any substance, we have to find the form of J. So basically J is equal to rho V. So here rho Vd basically, because the velocity is in the form of drift velocity. So J equal to rho V, and you can write it as NeVd. N is the number density. Rho is the complete density, that means charge per unit volume. N is the number of particle per unit volume. So as the charge per particle or charge of electron is E, so you have rho equals to N. So that's like that. So you can write N square E by gamma plus Im omega. Okay. Now compare those two equations, J equal to sigma E and J equal to that. You have sigma is equal to N square by gamma plus Im omega. Okay, gamma plus I. Now this is the conductivity of a plasma. Generally, the gamma value is very small compared to the conductor. In conductor, the gamma value may be greater than plasma, and in that case, sigma is very large. Okay, this sigma is very large for plasma. Sigma is very large, and it has two components. Okay, only one is real component and another is imaginary component. তো আমরা এই জিনিসটা আগের দিন ডিরাইভ করেছিলাম এই সিগমার ব্যাপার। তো আজকে আমরা এর ইমপ্লিকেশন গুলো দেখি। তো রিমেম্বার দিস ইকুয়েশন, for sigma. Sigma is equal to n square by gamma plus I omega. Of course, for non-collisional term, that means if gamma is 0, then only it will be purely imaginary. Okay, for gamma equal to 0, it will be purely imaginary. For non-collisional plasma, that means if gamma is 0, the sigma will be purely imaginary. Okay, so note this equation. Now, I am going to discuss the nature of electromagnetic waves within a plasma. We have a plasma substance as a medium, an electromagnetic wave which passing through it. So, what would happen to the electromagnetic waves, or the nature of the electromagnetic wave? Will it be identical to the conductor or dielectrics, or it will have some different criteria or different features when it enters the plasma? So, in order to do that, we have to study the Maxwell equations. So first of all, for source free region, rho and J is 0. Okay. So for source free region, here the region is plasma. The rho value of the charge density and the current density is 0. But one thing is that for plasma, sigma is large. The conductivity large. So again you have the equation J equal to sigma E. So even if you do not impose any external sources, suppose you have no external sources, no rho, no J, but still it will there be some effective J, because J equal to sigma E. For high conductivity of plasma, and in the presence of external electric field, there will be some aqueous current density, volume current density J. So J cannot be 0. Rho may be 0 or may not be 0 depending on your setup. Okay, if you impose some external charge density, external source, then rho may not be 0, but in general case, if you don't put any source, any external source, then rho is 0. But J never be 0. Okay, because J equal to sigma E and sigma is very high. Now, we have the Maxwell equation. Divergence of E is equal to 0. Divergence of B is always 0. Curl E equal to minus del B by del T, and curl H equal to J plus del B by del T. Okay, J is equal to del B by del T. Now it is the electric displacement vector, and I am considering the non-dielectric substance. Plasma is not is not the dielectric substance. So here D can be written as epsilon naught E. Okay, electric displacement vector D is equal to epsilon naught. Okay, so you can write curl of H is equal to J means sigma E plus this is epsilon naught del E by del T.
সেখানে এপসাইলন
Are you okay with this situation? কারণ যেহেতু এটা নন ডাইলেকট্রিক সাবস্টেন্স, না এটা নন ডাইলেকট্রিক সাবস্টেন্স আমি ধরে, ঠিক আছে, যদি ডাইলেকট্রিক মিডিয়াম হয় ডাইলেকট্রিক কনস্ট্যান্ট কে এখানে 1. Okay, so I think all you are okay with this equation. The normal Maxwell equation, first one, second one, third one. The only changes is here, even not in the presence of the external sources, J may not be 0, so J is equal to sigma. Okay. Okay. Now from the last two Maxwell equations, this one and this one, you know, if you take actually this one and this one, this third one and the final form of fourth one, if you want to make the curl at the both sides, you will get z square E is equal to 1 by c square del 2E by del T2. The normal wave equations. Okay. Similarly, you also have grad square B is equal to 1 by c square del 2E by del T2. So both electric and magnetic field satisfies the wave equation. And the solution is very popular to you. Can anyone say the solution for E and B? What will be the solution for E? Anyone? What will be the solution? Pradeep.
Answer বলুন।
এর সলিউশন কি হবে?
is সমান E0 e to the power I into k dot r minus omega t.
I am taking minus I. Okay. It's not different. Minus I k dot r minus I. Thus, it matters with the direction. Forward going or reverse going. So it's my choice just. Okay. Similarly, B is equal to B naught minus I k dot r minus 1. So this is the plane progressive wave solution, typical plane progressive wave solution of the electric field and magnetic field under this media or under this plasma system. So can you say what is wave? What is actually wave? What is the definition of wave? What is the definition of wave? How can you define wave in a single sentence or so? Single or double sentence? A wave is nothing but propagating disturbance. Okay. The propagating disturbance. And thus disturbance is oscillatory disturbance. That means if you put some disturbance here, it will propagate, and in this process, it will make the particles of the media oscillate. Okay, the simultaneous oscillation of the particles of the media. And this E and B actually represents, it is a function of space and time, so it represents the oscillation profile of the particles of the media. Okay, the particles at R, the position of the particles are from the equilibrium position at any particular instant of time t. And for different t and for different space, he has a different value. So this is called the wave functions basically. So field, what is field? So in this point of view, E and B, which fields are basically the wave functions. So E and B are nothing but wave functions here. Okay. Now you can put these solutions here. Especially I am trying to put it in the fourth Maxwell equation. So as B equal to mu naught H, so you also write H equals to H naught e to the power minus I k dot r minus omega. So now try to put it here. So curl H, what will be the result? Curl H means minus I k cross H, right? Curl H is basically minus I k cross H is equals to sigma E. Okay. And this is epsilon naught del E by del T. So what will be del E by del T? This is I omega of E. Okay, so K cross H is equal to like that. So that's basically I can write it curl H again. I can reverse it. Curl H is equal to sigma plus I epsilon naught omega of t. Can I write this? Any objection about this or the last equation I have written? Is it okay? Hello everyone, is it okay?
And minus I plus.
So actually this is Charles. K cross H minus I K cross H is equal to Charles. Okay, তো এখানে বসো। এখানে নিচে বসো, ওখানে কি দেখ। So Charles is like that.
মানে সাইকেল হয় তো নাকি?
সেরকমই ভাবতে পারো। এরকম ভাবতে পারো। So I have two equations. This one and the final one. This. So just put down these equations. Okay. Now go back to the Maxwell equation for dielectrics. Okay. So for dielectrics, you have the Maxwell equation. Divergence of D is equal to rho. Right? Divergence of D equals to rho. Divergence of B is equal to 0. Curl equal to minus del V by del T. And curl H is equal to J plus epsilon naught del V by del. So here epsilon naught and epsilon R del E del T. This is for dielectric. Okay, this is for dielectric with dielectric constant epsilon R. Right? Okay. So for source free dielectric, this J will be 0. This rho will be 0. Okay. For source free dielectric, this is 0. This is not like the plasma. In plasma, even you don't put any source, there will be some effective J. But for dielectric, there is no J here. So the effective equation will be like that. Okay. It's like that. And if you put the solutions, P equals to E naught e to the power minus I A dot R minus omega T, then what will be del E by del C? Del E by del T will be I omega. So this is I omega epsilon naught epsilon R into E. So here curl of H is equal to that. Can I write this?
Yes, ঠিক আছে।
Yes. So this is the Maxwell equations with dielectrics and without source. And previously we have the Maxwell equations within plasma. The last one is curl of H is equal to curl of H was actually কত ছিল এখানে বলো একটু কত ছিল I omega epsilon কত ছিল বলো
সিগমা
সিগমা আর কি ছিল
I omega plus sigma into E ছিল I omega epsilon naught plus sigma into
সিগমা প্লাস আই ওমেগা এপসিলন নট এটা ছিল,
এটাই
এটা ছিল তো। ওকে, তো এখান থেকে আমি এখানে আই ওমেগা এপসিলন নট কমন নিয়ে নিলাম, তাহলে কি পাবো? 1 মাইনাস আই ইন্টু সিগমা বাই ওমেগা এপসিলন নট ইন্টু ই। Now compare these two equations. This is for dielectric with dielectric constant epsilon r. And here it's a plasma, it's not a dielectric. Here also you don't put any external sources. Identically here also there are no identical sources. Now if you compare that, due to the property of plasma into J equal to sigma E, so the high value of sigma, there will be some effective dielectric constant here, effective electric permittivity. So this is epsilon effective. Okay, so epsilon effective is equal to 1 minus into I sigma by omega epsilon naught.
ওটা আরেকবার বলুন।
এই দুটো ইকুয়েশন কম্পেয়ার করো, এখানে ডাইলেকট্রিক কনস্ট্যান্ট কি ছিল? এপসিলন আর। তো ইফেক্টিভলি এটাকেও তুমি ভাবতে পারো দিস ইজ দ্য ইফেক্টিভ ডাইলেকট্রিক কনস্ট্যান্ট ফর প্লাজমা or effective electric permittivity, effective relative electric permittivity for plasma. And this is sigma and omega dependent. Okay, for dielectric epsilon r was constant for a particular medium. If you use the sulfuric acid, the epsilon r is constant for that. But here but here the effective electric permittivity is not so constant. It depends on the frequency of external electric field and also the conductivity of the medium, conductivity of the plasma. Okay, so this is called the effective electric permittivity. So comparing with the dielectric medium, you can find there are some effective dielectricness within the plasma. Plasma is not a typical dielectric, but it gathers some dielectric-like property with effective dielectric constant like that. Okay. So epsilon effective is equal to 1 minus I sigma by omega epsilon. Now already you have the form of sigma, right? Already you have the form of sigma. What is the value of sigma? Sigma value কত ছিল বলো? Oh? n square by gamma plus I omega, im omega. Right? Okay. So this is the form of effective dielectric constant, and clearly it has some real component, also it has some imaginary component. Now case 1, I am considering case 1. Today we shall focus on this case 1 where gamma is 0, that means non-collisional plasma. Actually this is not possible, gamma cannot be 0, but we can neglect it. Okay, the effect of collision may be neglected with respect to the other parameters like omega. If omega be very high, then you can neglect this gamma with respect to that. Okay, so in that condition, you can neglect this gamma and it is called the non-collisional plasma. So today's discussion is about the non-collisional by omega square, where omega p is equal to n square and root over of them. So this is called the plasma frequency. This is plasma frequency. In the previous class, I have just written this equation. So today this is a derivation of this plasma frequency. Okay, can I write this? So for non-collisional plasma, we have the effective dielectric constant epsilon effective is equal to 1 by 1 minus omega p square by omega. And look at the expression for plasma frequency. It depends on the number density of their constituents. Electrons, ions, not the neutrals. It does not depend on the density of the neutrals, of course. And the size of the particle. Size means mass. Sorry, not size is mass. Okay. But for if you consider electron, the mass of electron is constant. So basically, you can say omega p is proportional to root over A. So plasma frequency is high for the higher particle number density. That means for higher density. Okay. Now, you know the refractive index. N is equal to root over of epsilon r. So here effective refractive index, N effective, is equal to root over of epsilon effective. So here N square effective is equal to that. So 1 minus omega p square by omega square. Okay. And do you know from your HS standard what is refractive index? Okay. Not only in HS standard, from 10th standard, refractive index is the ratio of the velocities of light in the free space and at that particular medium. So you have this is c square by v square. So c square by v square is equal to 1 minus omega p square minus omega square. Now v is the velocity, or basically it is the phase velocity of a typical wave. So v equal to omega by k. So you can write this is k square c square by omega square. K square c square by omega square. This is equal to 1 minus. So you can write it omega square minus omega p square by omega square. Okay. So you have k square equal to 1 by c square into omega square minus omega p square. And if you take common omega here, okay, omega here, so you have omega square by c square, okay, omega square by c square into 1 minus omega p square by omega square, right? So what is omega by c? Omega by v is equal to k. So you can say that omega by c is the dielectric constant of the free space. So you can write it is suppose k0. It is not the dielectric constant, it is the wave propagation vector. So wave propagation vector in the free space. Okay. So you can write k square is equal to k naught square into 1 minus omega p square by omega square. Okay. So the wave propagation vector within the plasma is dependent on the external frequency, omega, and also the plasma frequency, that means the plasma density. Omega p square is basically proportional to n. So that's basically some constant into n by omega square. Okay, so the dependence of electromagnetic wave within the plasma can be written in this form. Okay. So we we have the relations of wave propagation vector in different media, in free space and the plasma, and also we have the relation of effective dielectric constant of plasma medium and any effective dielectric medium, and they are already derived. Already our derive করে দেখিয়েছি. So this is so important. Okay. Now what is the outcome of this equation? Okay. To analyze the outcome of this equation, at first you have to know the flow of energy through the electromagnetic wave. And already you have found from Poynting theorem. Okay, the Poynting vector represents the intensity of flow or energy per unit area per unit time. So in order to do that, you have to calculate a Poynting vector here. A Poynting vector. So Poynting vector is basically E cross H, right? But if E be imaginary, he has the real component and also the imaginary component, then you can write it is half of E cross H plus E star cross H. So simple. Okay. And you have the Maxwell equation. Curl E equal to minus del V by del T, that means minus mu naught del H by del T. Non-magnetic substance. I am considering the non-magnetic substance. Otherwise, you can say this is mu del H by del T. So from here, what is curl E? Curl E is basically minus I K cross E. And this is equal to minus mu naught I omega H. Okay. So then H is equal to K cross E by mu naught omega. Okay, H is equal to K cross E by mu naught omega. So you can write this is half of mu naught omega, then E cross K cross E plus E star cross K cross E. Okay, just like that. So here you can write 1 by 2 mu omega K into E square, that means mod is, K into E dot E minus E into E dot K. Okay. Here also K into E star dot E minus E into E star dot K. And if you take the average, S average, you can get, it is a homework for you to find this calculation. You will get 1 by 4 mu naught, 1 by mu naught mod of E square into real of K. Actually here, you have to take the real of that. So this is the real part of that. So the S average will be 1 by mu naught omega mod E square multiplied by the real component of the wave propagation vector K. Okay. So this is so important. I am writing this equation here. The Poynting vector of electromagnetic waves within the plasma S average is equal to 1 by কত ছিল 1 by mu naught omega mod of square kr suppose real component of this. So yeah, okay. Now go back to this equation. Whenever you have omega p less than omega, or alternatively omega greater than omega p, then it is real, right? Average Poynting vector. So the electromagnetic energy will flow through the plasma. In that case, whenever omega greater than omega. But look at the case where omega less than omega. Whenever you have omega less than omega p, k will be completely imaginary. Okay, and in that case, you have never that sort of electromagnetic wave with frequency lower than the plasma frequency will go through the plasma. Plasma will not accept this. Okay, suppose that's the medium here. Okay, that's the medium here. Suppose this is plasma with plasma frequency omega p. Now, a wave peak incident on that with omega less than omega p, it will not go down through that. So there will be some possibilities. The waves may be absorbed here, absorbed in that surface, or may be reflected. So in further calculation, we can show that actually it will reflect. And in order to do that, you have to calculate the transmission coefficient and the reflection coefficient. Okay, the reflection coefficient is actually 1. Or some sort of less than 1, it may be, there may be some absorption and there will be some definite reflection, but there is no transmission to the plasma whenever omega less than omega. Okay, so this principle is actually used to radio communication. You know the frequency of radio wave is very small. Okay, the frequency of radio wave is very small. So we have the plasma state in our atmosphere, natural plasma state, it's ionosphere. Okay, ionosphere. Okay. And in that case, radio frequency, the frequency of radio wave is less than the plasma frequency of ionosphere. So naturally it will reflect. So while the radio communication, you can use this plasma principle like that. Okay, so that's the outcome. That's the application of plasma for radio wave communication. Okay, we shall show it in the next subsequent classes. How can this reflection coefficient is non-zero, but the transmission coefficient is 0. Transmission coefficient naturally is 0 because Poynting vector is 0. But we have to show the reflection coefficient is non-zero. And how can you maximize the value of reflection coefficient? So the absorption will be less and the radio communication will be of higher efficiency. Okay. Okay. Plasma state, they are ionized states, so they can treat as a plasma. না অ্যাকচুয়ালি আমার নিচের লেয়ার এখানে হোমোজিনিয়াসের উপর ডিপেন্ড করছে না, যদি কিছুটা ঢুকে যায় তাহলে আবার সেখান থেকে ব্যাক করবে। তো আমরা এটা একটা এমন ধরেছি ওমেগা লেস দেন ওমেগা পি এন্ড ওমেগা পি ফর দ্য লোয়ার স্টেট অনলি, দ্য লোয়ার স্টেটের চেয়ে কম হলেও তারা ফিরে আসবে। ওকে, now we have to calculate further how plasma can act on the electromagnetic field also. So go to the last equation, last two equations. Okay, curl E equals to minus of del V by del E. It will yield minus I K cross E is equal to minus I omega mu naught H. So K cross E is equal to, clear? Now curl B is equal to curl H basically equals to actually epsilon naught epsilon effective sorry I omega epsilon naught epsilon effective মানে যে পার্ট থেকে এটা এসেছে effective কথাটা effective এর মধ্যেই আছে। Am I right with this equation? আমি জানি না, দেখে বলো এটা ছিল তো। কেউ কি তোমরা লিখছো না নাকি বলো? আর এটা ঠিক লিখেছি তো ইকুয়েশনটা? হ্যালো, ঠিক আছে, একদম কনফার্ম বলো, ভুল হলে কিন্তু ভুল হয়ে যাবে। ওকে, so curl H is equal to minus K minus I K minus I K cross H is equal to that. So K cross H is equal to minus omega epsilon naught epsilon effective E. Now take K cross H. From here K cross H. It will be minus I omega epsilon naught epsilon effective K cross E. Now you have K cross E is equal to that. So you have minus I omega square mu naught I হবে না minus omega square epsilon naught mu naught epsilon effective H. Okay, so K cross of that is equal to G. So I am writing this equation again. K cross H is equal to minus omega square. What is mu naught epsilon naught? 1 by C square. C square epsilon effective H. So this is K naught square. Okay, K cross H is equal to minus K naught square effective epsilon effective H. Now again take the dot product with K at the both ends. So K dot K cross H. So it will be minus K naught square epsilon effective K dot H. Obviously from the left hand side it is 0. K is perpendicular to K cross something, so it is 0. Okay, so K cross is equal to 0. So here we have two conditions. Condition 1, epsilon effective is 0. Okay, or আমার যদি এটা 0 হয়ে যায় তাহলে দুটো কেস হতে পারে। একটা কি K dot is equal to 0, এটা একটা হতে পারে, আর একটা কি হতে পারে epsilon effective is equal to 0. So case 1 epsilon effective is 0. Now go to the first equation. Whenever epsilon effective is 0, then you can write K cross is equal to 0. Then you can write k into k dot h minus h into k square is equal to 0. H into k square is equal to 0. So from here you can write k is in the direction of h. Okay, k is in the direction of h. The direction of k and h in the same direction. Then you can write this is equal to 0. If you have k is parallel to h, then this is also h into k square, and this is also h into k square. So there is 0. Okay. So the outcome of this condition, whenever you choose epsilon effective is 0, then you have k proportional to h. K is parallel to h. So whenever k is parallel to h, then what will be e is equal to k cross h. Okay, equal to k cross h. So k and h are parallel. So what is e? 0. Okay. So it is not the electromagnetic waves. Clearly, evidently it is not the electromagnetic wave. For electromagnetic wave, both electric field and magnetic field are non-zero. Okay. But here, P is 0. From here E is equal to 0. Okay. And H is parallel to K. So K is the wave propagation vector, and the oscillation direction of oscillation is in the same direction of K. So this is like longitudinal wave. This is not the transverse wave, right? So whenever you choose plasma effective dielectric constant of plasma be 0, then it will not entertain the electromagnetic wave to go through it. It is only the magnetostatic wave or magnetic wave, and which is parallel in the direction of wave propagation vector. So this is the longitudinal magnetic wave, not the electric wave. Okay, not the electromagnetic. So this is for case 1. Now the second case, case 2. Case 2, k dot is equal to 0. So k is perpendicular to h. Okay, k is perpendicular to h. Then go to this equation, k cross h. That means k into k dot h minus h into k square is equal to, this is not 0, right? This is not 0, so this is minus k naught square epsilon effective into h. Okay, so this is 0. This is 0. So k square is equal to k naught square into epsilon effective. So this is k naught square into 1 minus omega p square by omega square. Now you have the typical plasma electromagnetic wave propagation. And clearly plasma does not allow any sort of frequency to go through it. It will only allow the electromagnetic waves with frequency higher than its natural plasma frequency omega p. Whenever omega greater than omega p, it will go through it like electromagnetic wave, and whenever it is less, it may be reflected, but it will not be transmitted. And in the second case, the non-Maxwellian wave, that means the only static magnetic wave can go through it, but it has not the property of electromagnetic wave. So that's the outcome of this class. Okay. If you have any question, you can share. Have you any question? এমনি হারমোনিক অসিলেটর যেরকম হয় সেরকম ঠিক আছে, শুধু ডিস্ট্রিবিউশনটা এরকম হবে যে p is equal to 1 by e to the power p মাইনাস মিউ বাই kt মাইনাস 1 এটা হবে। আর হারমোনিক অসিলেটর যেমন হয় তেমনই থাকবে, শুধু তার ডিস্ট্রিবিউশনটা এভাবে হবে বোসনের মতো, আর কিছু না। তো যখন পার্টিশন ফাংশন বের করতে যাবে এগুলো রাখতে হবে। এবার আন্ডার অ্যাপ্রক্সিমেশন তোমরা বাদ দিতে পারো, ইন জেনারেল ইট উইল ফলো দ্য বি স্ট্যাটিস্টিক্স। দ্য হারমোনিক অসিলেটর which follows the B statistics are called the bosonic harmonic. Okay.
স্যার হোয়াইট ড্রাফট এফেক্টে স্যার আগে যেটা বলেছিলেন স্যার ওইটা স্যার ভুলে গেছি, একটু নোটস পাঠিয়ে দেবেন।
নোটস পাঠিয়ে দেবো।